snapshot of electrochemistry chapter of CBSE so that we can discuss the JE part also. So if you see this, chapter, it says that electrochemistry is the study of production of electricity from energy released during spontaneous chemical reactions. The first line, if you see, electrochemistry is the study of production of electricity released during spontaneous chemical reactions and the use of electrical energy to bring about chemical reactions. So when we start with this chapter, electrochemistry, we are basically talking about two types of interactions. So either there is a chemical reaction and that reaction produces electricity, or the cell where electricity is used, a battery is used to carry out a chemical reaction. Okay, so that is called electrolysis, and that cell is called electrolytic cell. So a electrochemical cell and electrolytic cell. So if I tell you what is an electrochemical cell, it is a cell in which electricity is produced using a chemical reaction. Okay, chemical reaction leads to production of electricity. That is electrochemical cell. And if you see electrolytic cell, then we use electricity, that is we use a battery to carry out a chemical reaction. Okay, understood the difference between the two types of cells? Electrochemical cell, electricity is produced from a chemical reaction, and electrolytic cell, the electricity is used to produce a chemical reaction. So in one case, chemical reaction happens first, electricity is produced as a result of that. And electrolytic cell, the electricity is used first and chemical reaction happens because of that. Okay, that is the basic difference between electrochemical cell and electrolytic cell. So what you will see here is, in this particular chapter, they will start with electrochemical cell. Electrochemical cell is given here in the form of a diagram. So everybody can see this diagram? Yeah. So in this diagram, if you see the left side, okay, there is a zinc rod. So very interesting. You have a mechanism by which you can produce electricity. So if you see this, can you see the zinc rod over here? So this is a zinc rod. This is a zinc rod, and this is a copper rod. Okay, so there is a copper rod and a zinc rod. And what is this solution? This is a solution containing salt of zinc. So for example, ZnSO4. So ZnSO4 is a salt of zinc. Now ZnSO4 will break into two types of ions. What are the two types of ions? Zn2 plus and SO4 2 minus. Yes or no? These are the two types of ions which are produced as a result of ZnSO4 salt put in water. And this is a solution containing salt of copper. So if I see salt of copper, then CuSO4 is a salt of copper. And CuSO4 will break into, if you see CuSO4, it will break into Cu2 plus and SO4 2 minus. Yes or no? So ZnSO4 will break into Zn2 plus and SO4 2 minus ions, and CuSO4 will break into Cu2 plus and SO4 2 minus ions. So can you see that this particular solution, this is the solution, isn't it? This is the liquid solution of the salt, and this is the liquid solution of the salt. But what are the two salts? ZnSO4 is the salt solution, okay, on the left side. Sulfate solution. Which rod is put? Zinc rod. And in the copper sulfate solution, which rod is put? Copper rod. Okay. And what is this interesting thing written over here? Salt bridge. Okay. This is a salt bridge. And what is connecting the two wires? A wire. A wire is connecting the two rods. So if you see the zinc rod and the copper rod, there is a wire which is connecting the two rods. So if you see, this particular current is from right to left. If the current is from right to left, then the electron flow is from left to right. All of you agree? The direction of the electron flow is the opposite of the direction of the current. Or the current direction is from plus to minus, and the electron flow is from minus to plus. So when electrons are flowing from minus to plus, the zinc rod has which sign of the battery? Minus sign. And copper rod has which sign of the battery? The plus sign. So electrons always flow from minus to plus, and the current always flows from plus to minus. Is this also clear? So are we understanding what is happening here? We'll understand what first, and then we'll understand why. Okay, why is it happening like that? Okay, so now this is something which you also can do. Okay, in a lab, you can actually make this battery. I have done it. So it's not very difficult. So what all is needed in order to make this battery? Okay, if you see carefully, you need two beakers. You can see beaker number one, beaker number two, and you need water. Okay, so you'll put water in both the beakers. Water डाल दिया. Abhi, which salt will you put inside the first beaker? Zinc sulfate salt, ZnSO4, as I told you before. Which salt will you put in the second beaker? CuSO4. Now, what will happen to the salt of ZnSO4? It will break into Zn2 plus and SO42 minus. And what will happen to the copper salt in water? It will break into Cu2 plus and SO42 minus. After this, what do? We put a rod, a zinc rod in the first beaker. Okay, and we put a copper rod in the second beaker. We hold it with the help of a stand. Now, what is a salt bridge? Okay, now understand carefully. A salt bridge, okay, is filled with a jelly-like substance. Okay, the jelly-like substance. All of you have eaten jelly, custard jelly. You might have eaten custard jelly. It's very thick. It's neither very solid, neither very liquid. It is like very spongy. So that jelly is a fungus. Okay, it's an algae which is known as agar agar. So agar agar is a paste, a jelly-like paste. So that jelly-like paste is filled inside the salt bridge. A salt bridge is an inverted U tube. You can see it's an inverted U tube. So what you do is you hold the inverted U tube. So what you do is you put water in it, put the agar agar paste in it, and put a salt in it, like potassium chloride. Potassium chloride, okay? You put potassium chloride in that solution. So you put water, you put that algae, which is agar agar, so that whenever, if you remember, you have jelly powder in the market. So whenever you put that jelly powder in water and put it inside the fridge, you know what happens. You get a jelly by the morning, okay? Sometimes it's tastes like strawberry, and sometimes we eat it with custard or we eat it with ice cream. So just like that in water, in slightly warm water, if you put the powder of agar agar, but at the same time you put a salt solution. Which salt solution? KCl, potassium chloride, or even sodium chloride is okay. So you're putting a salt solution. That's why the salt solution ke wajah se, because of salt solution word, it is called a salt bridge because it contains salt. So once you make that solution, you stir it. Okay, water, agar agar, and KCl. You stir it. Now what you do is you take an inverted U tube. You take an inverted U tube, just like a U tube, and you fill it with that solution. So as you fill it, okay, it will go inside and it will fill till the complete U. Okay, now take some cotton and plug it. Take some cotton and plug it. Now this is a U tube. Inside the U tube, you have filled the jelly-like solution with the salt in it. So that if you let it remain at room temperature, it will automatically become jelly. So the salt solution is inside, but it is not able to flow through completely because of the jelly-like substance. So it is causing very viscous. It's viscous. Viscous means it is the salt ions are not easy to move. So you take this U and you invert it and you put it inside the two beakers. One U is inside the left beaker. Another side of the U is on the right beaker. Okay. Khushi, you're able to understand what I'm saying? It is all based on the diagram. Okay, whatever diagram I'm trying to explain, we are trying to understand how this particular cell works. Okay, so as I said, the inverted U tube is there. All of you can see the inverted U tube. It is a salt bridge, correct? And so you can see that this salt bridge has this jelly-like substance, and this jelly-like substance, which is agar agar, it contains the salt. Which salt? A KCl salt. So let's say K plus and Cl minus. Okay. So far you have understood what have we done. We have taken two beakers. In the first beaker we have put water with ZnSO4. In the second beaker we have put water with CuSO4. So the left beaker is zinc sulfate solution. The right beaker is copper sulfate solution. In the zinc sulfate solution, what have we put? Zinc rod. In the copper sulfate solution, what have we put? Copper rod. Okay. And what is the easiest thing in the world? Take a wire and attach both the rods. We have taken a wire and attached both the rods. And then we have the salt bridge. Okay, what did I tell you just now? What is the salt bridge made of? It is made of a jelly-like substance like agar-agar paste with a salt in it. What salt is it? KCl. Okay. So this is the construction of the electrochemical cell. Now please tell me if you have understood the construction of the cell. All of you have understood? You can give me a thumbs up. Understood, Kushi? Rajwan? Okay, very good. Now, see, this is the construction, okay? This is the construction, not the working. I have to teach you the working. Okay, now the working is, a little something which you have to understand very clearly. Otherwise, there's no point. You have to understand the working. So, what I'll do is, there is a screen. Yeah. So, in order to show the working, I'll show one left side at a time. Okay, so what I'm going to do is, okay, all of you can see the whiteboard. Now, in this left beaker, okay, this is known as oxidation half cell. This is known as oxidation half cell. So, what is oxidation half cell? The left side. And what is the left side? It is a zinc sulfate solution. So, I'm going to write Zn2 plus and Zn2 plus and SO42 minus. Now, there is a zinc rod. That is a zinc rod which is immersed in the zinc sulfate solution. So as I said, zinc sulfate solution will have Zn2 plus and SO42 minus. Now what is happening very interestingly is that zinc, everyone knows what is a zinc atom. If you see a zinc atom, look here, a zinc atom in atomic structure, okay, the outermost configuration of zinc is 3d10 4s2. So how many free electrons does it have? It has two free electrons. Okay. So when it has two free electrons, there is a nucleus of zinc and it has many orbits, one, two, three, four. Okay. And there are two electrons in the outermost orbit. Okay. Now just imagine that this is a zinc rod. Now what happens is the zinc atom leaves these two electrons. Okay. It leaves these two electrons. It leaves these two electrons on the rod. It leaves the two electrons of the rod and enters the solution as Zn2 plus. What does it enter the solution as? So its outermost orbit is gone and it has three orbits left out of four. And what has it become? Zn2 plus. Okay. So what do we know about oxidation reaction? Zinc is a rod, Zns. So what does it become? Zn2 plus aqueous plus two electrons. Okay. So if I have to write the reaction of zinc, and if zinc is going inside the solution, zinc atom is entering the solution as Zn2 plus. So can you imagine a lot of penguins which are jumping into the ocean? Can you imagine a lot of penguins jumping into the ocean? So the zinc rod is jumping into the water. It is jumping from the rod into the water. So this is because zinc is very reactive. Zinc atom can give its electrons easily. So the zinc atom leaves its two electrons on the rod and enters the solution like a penguin jumps into water. It enters the solution as Zn2 plus. So can you imagine that the number of Zn2 plus will increase? The number of Zn2 plus ions will increase. Okay, all of you can draw these also. Draw this as you write it down. So the number of Zn2 plus ions is increasing in water. All right. And what is happening to the electrons? Can you imagine a lot of electrons which are left on the rod? A lot of minus, minus, minus. Yes or no? So zinc is leaving. So zinc is leaving its electrons on the rod and entering the solution as Zn2 plus. Now please tell me, all of you have understood what I just explained. What is happening? Okay, can everyone tell me that you have understood? You can text me. Prajwal has understood. Khushi, have you understood what is happening? Zinc is entering the solution as Zn2 plus. Okay, and it is leaving two electrons on the rod. On the rod. Khushi, if you have any doubt, let me know. Khushi, have you understood? Khushi, you can let me know if you have understood what's happening. If you want me to explain again, you can tell me. Okay, very good. So Khushi has understood. So now tell me, what is happening on the left side of the left side of the construction? The zinc sulfate solution. Okay, the zinc sulfate solution. Zinc atoms are entering the solution as Zn2 plus ions, and the electrons are left on the rod. Okay, this will lead to two different effects. Understand very carefully. If the number of electrons will increase on the rod, won't they push themselves out of the rod because of repulsion? Won't electrons start flowing outside? Will the electrons start flowing outside if there are a lot of electrons on the rod? Yes or no? So because there are a lot of electrons on the rod, they will start flowing outside. Okay, and what is happening in the solution? As Zn2 plus is entering the solution initially had equal number of Zn2 plus and SO4 2 minus, because ZnSO4 was put inside the solution. So Zn2 plus and SO4 2 minus were equal in number. But now what is happening? From the rod, Zn2 plus ions are entering the solution. So the solution is becoming positively charged. What is the solution becoming? The solution is becoming positively charged. Why? Because more and more Zn2 plus ions are entering the solution. So that is why it is becoming positively charged. So now tell me, who comes to the rescue? Who will come to the rescue of this? Remember the salt bridge? Yes or no? Remember the salt bridge? So the salt bridge has which ions? So what will happen is, if the solution becomes positively charged, it will attract the negatively charged Cl minus, Cl minus, Cl minus ions from the salt bridge. Salt bridge may say you will get the Cl minus ions entering the solution because the solution is becoming positive. So it is attracting the negative Cl minus ions from the salt bridge. So the solution is attracting the Cl minus ions from the salt bridge, as a result of which I think you guys can let the screen work on its own so that there is no disturbance. Okay, so don't minimize it. So what is happening here is you will have Cl minus entering the solution. So this is how the left side is working of the construction cell. Okay, how is the left side working? You want to note it down? What is happening on the left side? Zinc atoms are entering the solution as Zn2 plus ions. Okay, first point. Zinc atoms are entering the solution. So zinc atoms from where? Zinc atoms from the rod are entering the solution as Zn2 plus ions. Okay, first point. The second point, they are leaving two electrons behind on the rod. Okay, excess electrons on the rod, excess electrons on the rod will start flowing outside from the rod, will start flowing outside from the rod to the wire. Yes or no? Okay, all of you can write down these points. Now what will happen? The solution has increasing Zn2 plus ions, making it positively charged. Hence, Cl minus ions from the salt bridge will enter the solution okay, and maintain its neutrality. They need to maintain the neutrality of the solution. So this is the working of which side? This is the working of the left side. Are you following? Okay. So this is something important. I'll see if I can save this. Okay. Now tell me if you have understood the working of the left side of the electrochemical cell. Okay, Khushi, Prajwal, everyone. Harshit, Khushi, understood? Okay, very good. So this is what is happening on the left side. So please make sure that this is saved. All right. So let's look at the next one. Okay. Now let's look at the next one. So now I'll be doing the right side of the cell. Okay. Now the right side of the cell is, as all of you know, which solution is there? Copper sulfate solution is there. So this is CuSO4 solution. So in CuSO4 solution, which ions will be there? Cu2 plus, SO4 2 minus. Cu2 plus, SO4 2 minus. Right? These are the ions in the solution. Now what will I show? I will show which rod? I will show the copper rod. Yes or no? This is the copper rod. And this copper rod is connected by a wire, okay, from the zinc rod. Now what did we just study? We saw that what is coming from the zinc rod to the copper rod? Electrons are coming, yes or no? The electrons are flowing from the zinc rod to the copper rod. So what will happen to the copper rod? The electrons will enter, yes or no? Electrons will enter the copper rod. So as they enter the copper rod, you will have the copper rod becoming negatively charged, correct? Okay, these electrons are coming from the zinc direction. Now what will happen is the Cu2 plus from the solution, the Cu2 plus from the solution, don't you think it will be attracted to the rod? It will be attracted to the rod. So which reaction is this? This is known as reduction reaction. Okay, like earlier we wrote the oxidation reaction. Now we'll write the reduction reaction. And what is the reduction reaction? Cu2 plus from the solution, Cu2 plus aqueous, okay, will combine with two electrons to form Cu solid, will form to form Cu solid. So this is known as which half cell? The previous one was called oxidation half cell. This is known as reduction half cell because what is happening on this half cell? Reduction is happening. Okay, and what is reduction? Electrons are accepted by copper. When copper accepts electrons, it gains electrons. Whenever there is a gain of electrons, it is known as reduction. Okay, I hope all of you are understanding. Now what will happen is, understand this carefully. SO4 2 minus is left behind, no? If copper from the solution, if copper is getting deposited, copper is getting deposited, copper is getting deposited, copper is getting deposited, then SO4 2 minus is increasing. If SO4 2 minus is increasing in the solution, which means which charge is increasing in the solution? Negatively charged. The solution is becoming negatively charged. Now everyone, remember the salt bridge? All of you remember the salt bridge? There was a salt bridge, and this salt bridge, okay, had that agar agar paste. Now remember which were the positive ions in the salt bridge? K plus. I had told you that there are K plus ions and there are Cl minus ions in the salt bridge. So the K plus ions will cancel out the negative charge. So the K plus will balance SO4 2 minus. Okay, and once it balances SO4 2 minus, then it becomes neutral. That is the whole purpose of the salt bridge. that it maintains electrical neutrality. Okay, it maintains electrical neutrality. So this is the working of the right side of the electrochemical cell. This side is known as reduction half cell. So left side is called oxidation half cell. The right side is called reduction half cell. Okay, I hope you are following. So now, I hope you have made, I will make some points here also. So I'm writing down the points over here. Okay, what are the points? Electron flow from the zinc rod, okay, from zinc rod to copper rod. Please everyone write this. Electrons flow from zinc rod to copper rod. Copper rod gets electrons and becomes negatively charged, okay, and it attracts which ion? CO2 plus ions from the solution. It attracts CO2 plus ions from the solution. Okay, this is called reduction. Okay, this is called reduction. The solution, okay, is negatively charged because of excess which ions? SO4 2 minus ions, because copper ions are getting deposited. So SO4 2 minus ions, okay, are extra in the solution. Okay, so who comes for the rescue? K plus ions from the salt bridge enter the solution, thus making it neutral. Understood? These are the points for reduction half cell. Okay, so these are the points for reduction half cell. Understood? Oxidation half cell and reduction half cell. You can note it down. Harshit has understood. Khushi, you can also tell me. Khushi is saying, can't we build cathode without actually using it by just reduction? Is it compulsory to use copper rod? Well, copper rod and zinc rod. Okay, there is a secret. What is the secret? The secret is that if I attach a zinc rod and a copper rod, okay, this is very important. If I attach a zinc rod with a copper rod, one of them has a tendency to lose electrons, the other one has a tendency to gain electrons. Now you tell me, which will easily lose electrons? The one which is more reactive or less reactive? Khushi, can you answer this? Who
More
will?
reactive.
Correct. The one which is more reactive will easily lose electrons. So if zinc loses electrons easily, then who will be the one who will gain electrons? Copper. Zinc will lose electrons, copper will gain electrons. So zinc will become the oxidation half cell because there is a loss of electrons. Copper will become the reduction half cell because there is a gain of electrons. And where are these electrons flowing from? They are flowing from the outer circuit, from one rod to another rod. And how are these rods connected? Through a wire. Okay. And where is the loss of electrons taking place? On the rod. Zinc atom from the rod is losing two electrons to the rod and entering the solution as Zn2 plus ions. Copper from the Cu2 plus of the solution is gaining electrons which are on the rod. So copper is getting deposited in the reduction half cell and zinc is getting oxidized in the oxidation half cell. So just imagine I have a zinc rod. Let us say this is a zinc rod. This rod will decrease in size. Why? Because zinc atoms are entering the solution. So it will decrease in size. And look at the copper side. On the copper side, the copper is depositing itself on the rod. So the size of the rod is increasing with time. Are you following? So the size of the rod is increasing in the copper half cell and the size of the rod is decreasing in the zinc half cell. Have you understood? Kushi? Understood now? Okay, perfect. ठीक. I hope you wrote the points as well. So now let's look at the construction completely. I think there is just 3 minutes left. So if all of you can have a look at the. All right. the earlier diagram which we had. Okay. So now, what do you learn from this diagram? You learn that, uh, yeah, you learn that this side is which half cell? Oxidation half cell. And this side is which half cell? Reduction half cell. Okay. You knew what was happening. Here the zinc atoms were coming out of the rod, and here copper was getting deposited on the rod. Okay, that's why it was reduction, and here it was oxidation. And what is the important role of the salt bridge? Very important. In one line, the answer is it is maintaining the electrical neutrality, okay, of both the solutions, because on the left side the solution is becoming more positive, so Cl minus ions are entering to neutralize it, and on the right side the solution is becoming more negative, so K plus ions are entering to neutralize it. That is why salt bridge is so important. And you know the reason why electrons are flowing from zinc to copper. So is this cell understood, everybody? Is this particular cell understood? Electrochemical cell. Yes. Khushi, understood? Okay. Okay. So what I would like you to do is, you can let me know the topics in electrochemistry which you would like me to focus in the next online sessions. Any particular topics in electrochemistry, because in electrochemistry there is electrochemical cell, there is Nernst equation. It is quite a big chapter. There is Faraday's laws of electrolysis, there is molar conductance, and finally there are types of cells. So there are 5 to 6 topics in the chapter. Okay. So today's session, I just wanted to discuss about electrochemical cell and how it works. Okay, so that we can take it up in the next session. So you can also let me know if you are available after school, okay, in the evening, when you reach home. Then we can probably have some sessions, in the week rather than just the Sunday. We should have more sessions. So you can tell Anjali ma'am which